4.7 for pre-calc. What we're going to be doing in this section is we're going to be finding the inverse of trig functions. Now I know we've done that a little bit already using the inverse, but we want to go into a little bit more depth about how to do that. So the objective is going to be to use and understand the idea of inverses in respect to trig functions. So getting right into this, let's talk a little bit about what we have here. So on your notes you can see we have tangent of theta equals 2. So the idea of this is that if we want to solve for an angle, that's what the inverses are used for. Inverse is kind of called the angle finder. So if I wanted to actually solve for theta, what I'm really doing is I'm taking the inverse tangent of both sides. So if I take the inverse tangent of this side and I take the inverse tangent of this side, the inverse tangents will cancel out and we will be left with theta equals the inverse tangent of 2. Now, certain things we have to be able to use the calculator for. So if we want to use the calculator, then we will say the inverse tangent of 2 using our calculator. We go second tangent 2 equals, and you notice we get 63.4. Well, that's in degrees because that's the mode that our calculator's in. So if we go 63.4 degrees, that's our answer in degrees of tangent. Now, if we wanted it in radians, then what we would do is we would do the inverse, but we have to change the mode to radians first. So change to radians. And then we would do the exact same thing. And in fact, you could just hit enter again, and notice it does the exact same thing, and now we have 1.1 as our answer. So the second one would be 1.1 radians. Okay, so I'm not going to bother going over this. You can do this on your own. If you have a calculator, go ahead and do that, and then type your answers in the Edpuzzle. So you should have gotten 47.5 degrees for degree mode, and you should get 0.83 radians if you're in radian mode. So that's how you use the calculator to do it, but essentially we need to understand the purpose of taking an inverse is to find an angle. So what we're going to do is we want to make sure that we understand two different things. Here is an approximation using the calculator. The next part is going to be using the unit circle, although with me, I don't typically like to use the unit circle all that often, so we're not going to use it that much here. But what we want to understand is if you're looking at it, and I know that part of this is covered up by the camera, but if you look around the unit circle, it's basically giving you all of your x and all of your y values for every single angle and every single radian angle. So if you notice over here, we have 2 pi over 3. The x value represents the cosine, so that means the cosine of 2 pi over 3 or the cosine of 120 is always going to equal negative 1/2, and the sine of 2 pi over 3 or sine of 120 is equal to the square root of 3 over 2. These are just the coordinates that we have, the x value and the y value, or the cosine value or the sine value at each of these angles all the way around. So the question is when we get to sine of theta equals square root of 2 over 2, you should not need a calculator to solve this. You should be able to use either your unit circle, your knowledge of your unit circle, or you should be able to use special right triangles. So what I want to make clear is that using special right triangles is really important. So what I'm going to do is I'm going to look at this, and I see the square root of 2 over 2, and I think of the sine function as being opposite over hypotenuse. So what I do is I can draw a triangle out, and I'm going to put my theta right here, and my opposite side is going to be the square root of 2, and my hypotenuse is going to be 2. Now, if you don't already recognize the triangle of what it's going to be, then go ahead and figure out what the third side is going to be. If you want to figure out the third side, you would realize that this side is going to be the square root of 2, which means that you should then be able to recognize this triangle as being a special right triangle, and you should be able to recognize that your theta is 45 degrees. So, therefore, our first answer here is 45 degrees. Now, here's the issue. We get a second answer to this too, because if you look at your unit circle, or if you look at the concept that we've always talked about, that we have all students take calculus, this means that all of our trig functions are positive. This means that our sine functions are positive, our tangent functions are positive, and our cosine functions are positive. Well, if you look at a 45-degree angle, that's just the reference angle. But we do know that sine will be positive in this quadrant. So therefore, if you're looking at your unit circle here, square root of 2 over 2 is going to work for a 45-degree angle. But we also know that in the second quadrant, our sine is also positive. So we have to look and see where is our 45-degree reference angle at, and it's at 135 degrees. So our second answer is 135 degrees. So you do get two answers when you're solving this equation. So the question is, if we're going to get two answers for these, because sine is actually going to be equal to the square root of 2 over 2 at two different points, if we get two different answers, then why, when we did the calculator, are we only getting one answer? And there's a good reason for that. And that's what we're going to go over on the next slide. So this is a little bit messed up, so it's a little bit better on your paper, so just kind of follow along on your paper. Here's the idea. So if we have, if this is our unit circle, basically here's what we need to understand. We do have some restrictions when we take the inverse in our calculator. And the restriction is that, I'm just going to draw new axes since they're covered up, but you see them on your paper. The restriction is that when we take the inverse sine, the restriction is always going to be on the right-hand side of the graph. That is the only place that you can get an answer for an inverse sine, is on the right-hand side of the graph. So in the previous slide where we got an answer in the second quadrant, the calculator will never spit out that answer because it's only defined on the right-hand side of the graph. Basically, we say it's only defined from negative pi halves to positive pi halves. Okay, so that's the reason why you'll only get one answer when it spits out. Notice first answer was in the first quadrant, second answer was in the second quadrant. If we would have by chance gotten an answer in the fourth quadrant, then the other answer would be in the third quadrant, but the calculator will only spit out the one that's in the fourth quadrant there. For cosine, cosine is only defined, and again I'm going to draw our axes here. Cosine is only defined on the top half. So we call that from 0 to pi. So that's only defined there. So you will find that you can get two answers for cosine, but typically your first answer, if it's positive, would be in this quadrant, and the other answer would be in the fourth quadrant where it's positive. But the calculator, if you're doing an inverse, will only define it right here in this quadrant. And then for tangent, if we draw these quadrants, tangent is the exact same as the sine. Okay, so it's the exact same as the sine, so it's only in this quadrant right here. Okay, so that is also from pi halves to negative pi halves. So that's the reason why the calculator only spits out one answer. But when we are actually solving equations and trying to find a theta, we need to realize that when you go around the unit circle, every value except for your zeros, ones, and negative ones are always going to be hit twice. And if you think about the way a sine graph or cosine graph looks, that should make a lot of sense to you. Because if you think about it, up here is positive 1, down here is negative 1. Every value in between 1 and negative 1 is going to be hit twice. This value right here is going to be hit again right here. This value right here is going to be hit again right here. So it's always going to have two answers in two places. So let's see how this works and do a couple of examples. We have cosine of theta equals negative square root of 3 over 2. So what I do is I draw my triangle because I want to try and identify what special right triangle I'm dealing with. There's my theta, because cosine is equal to adjacent over hypotenuse. I know that my adjacent side, and notice this negative sign here. So therefore I'm going to go, I know that my adjacent side is going to be square root of 3. My hypotenuse is going to be 2. Because my hypotenuse always has to be positive, I know my negative is coming right here. But again, this negative is not going to be that important, because when I draw my coordinates and I put in all students take calculus, I know that cosine is going to be negative in this quadrant, the second quadrant, and in this quadrant. So therefore, when I look at this, I should again see a special right triangle here. I should see, okay, if this is 2 and this is square root of 3, then this is going to be 1, meaning my theta for this is going to have to be 30 degrees. That's my reference angle. That doesn't mean it's at 30 degrees. It just means that's the reference angle of the special right triangle that we're getting. So the answer is not 30 degrees, but the answer is going to come from a reference angle in this quadrant that is 30 degrees. And so therefore the reference angle here that is 30 degrees, we have to be able to figure out what is the angle that is being created that gets us a reference angle of 30, and 180 minus 30 is 150 degrees. And if you were to put this into a calculator, you would get 150 degrees. So again, to get the second one, we go to the other quadrant that we're working out of, which is this quadrant. And again, we have a 30-degree reference angle because that's the type of triangle that we have, and because it's negative, we are in these two quadrants. So what angle would get us a 30-degree reference angle in the third quadrant? Well, it'd be 180 plus 30, 210 degrees. So those are your two answers to solve the inverse of this. Okay, let's look at the next one. Okay, we have tangent of -1. This tangent of theta equals -1. This one is much more difficult. Okay, but I'm going to try and illustrate this to you the best that I can. Again, what I'm going to do is I'm going to draw it out into a triangle. Okay, so I'm going to do a triangle first. So let's first of all, when we don't have a fraction, let's write it as a fraction. -1 over 1, and that is opposite over adjacent. Remember, anytime we're solving for angles with exact values, we're trying to get a value that is a special right triangle. So we're going to draw our triangle, put our theta in there, and because our opposite is -1 and our adjacent is +1, what you may not be familiar with this, but if we have the same legs on a triangle, even though that doesn't look completely like a special right triangle, just understand that this triangle and this triangle are the exact same triangles. So you should see that because the legs are the same from geometry, that our theta is going to have to be 45 degrees. So once again, when we do our all students take calculus, we need to identify the two quadrants where tangent is negative, because it's negative. So tangent is negative in the second quadrant and the fourth quadrant. So we need to know what angles will be created in those quadrants that are creating reference angles of 45. So in this quadrant, it would be 180 minus 45 is 135 degrees. And then we go to our fourth quadrant, and we create another reference angle that is 45 degrees, and that will be 360 minus 45, which is 315 degrees. So the idea of this is what you're trying to get at is you're trying to find, first of all, which two quadrants are you working out of, and two, what will your reference angle be? Once you know what your reference angle is, and once you know which two quadrants you're working out of, you can figure out what those angles are. So you're going to use what the tangent or sine or cosine is equal to create your triangle to try and determine what the reference angle has to be. Then you determine the quadrant and figure out what that reference angle, what it comes up with for our actual angle. What does it translate to for our actual angle? Remember, the answer is not 45. The reference angle is 45, and we come up with our angle by figuring out what would the terminal ray be with a reference angle of whatever you guys found. Okay? All right, so what I'm going to do is I'm going to stop the video right here because we're going to run out of our 15 minutes here, and then we're going to finish up the notes on a second part video. So go ahead and click on the second video now.